Welcome students. Today in this lecture we will discuss about the annual worth method or the equivalent annual worth method. This method is used for analyzing of cash flows, and this is also used for comparison among different alternatives in order to make decisions. In the previous lecture we already seen how the present worth analysis is used for solving problems related to comparison, both where the asset they have the equal life and assets with unequal life. In future lectures, I will also take up the future worth method, the rate of return method, and the benefit cost ratio analysis. So let us see what is this annual worth method. So the basic idea behind this annual worth method is to convert the complete cash flow diagram into a series of equivalent uniform annual worth, or the complete cash flow diagram is converted into annuities. So that is the basic difference of this with respect to the present method analysis, where we are converting the complete cash flow diagram at the present point of time. Here we are converting the complete cash flow diagram into annuities. This method is used to determine the annual values of all the receipts and the disbursements, or the cash inflow and outflow which are there in a cash flow diagram. Now if we have just net receipts, the basic objective is to select that alternative that will maximize the annual worth or annuities, because that is the kind of yearly profit that is being generated from any business. If we have just the disbursement or the cash flow within a cash flow diagram, the objective of any alternative that should be selected is the one that will minimize this expenditure, that is the minimum annual worth or the minimum equivalent uniform annual worth of the cost. In case we have a cash flow where we have inflows as well as outflows, that is both the receipts and the disbursement, then if we have to take the difference between the annual worth of the benefits and annual worth of the cost, and depending upon the sign, that is if the benefit minus cost values are coming out to be positive, then the alternative with the maximum positive value is the selected criteria. And if this difference is coming out to be negative, the one with a minimum expenditure, that is the minimum value, negative value, that will be the selected criteria, because that is the kind of expenditure. Now on similar lines, what we did for the present worth analysis, we can analyze the annual worth method. That is, in a cash flow we have certain receipts, we call these as benefits or the cash inflow. We do have the costs or the cash outflows or the disbursement. Then this complete cash flow should be transformed into annuities. So some annuities, they will represent the benefits or the receipts, and annuities, the downward annuities will represent the cost and the disbursement. So the criteria is, if we take up the difference, then if it is positive, then the maximum positive value is the selected one, because that is the maximum amount of profit that is being generated from a business. And if this is coming out to be negative, that is the cash outflow, then the minimum of the outflow is taken to be the selected criteria. Now whenever we are solving problems with the help of annual worth method or even with the future worth method, it's always better to convert any cash flow into the present worth, and then this present worth is converted into annuities. So a simple logic behind this is that it is easier to understand and easier to visualize. One can directly see or apply the standard formulas which are available for the conversion of P, F, G and A, so that can be readily applied. And it's always better if we just first compute the present worth and then we convert this present worth into annuities as shown in this one. So we have a cash flow, try to find out the present worth first, and once we have the present worth, then using the relationship between annuities and the present worth, this present worth is to be converted into annuities. In case we have a problem where we have unequal lives, then what we have discussed in the present worth analysis, that the repeatability assumption is to be taken into account. So in this case also, the repeatability assumption one must take into account if we have the different economic lives of the assets. Now, let us solve a problem based on the annual worth method. So this is the unsolved problem from the book of Riggs. And it says that there are two power inverters, alpha and beta. The various costs, they are given: the purchase cost, the purchase price, the annual operating cost, the salvage value and the estimated service life of both the alternatives, they are given. Of course, this is a case where we do have unequal economic life. The interest rate is given as 10%. We have to compute the annual worth of the two, and accordingly the decision is to be decided that which alternative should be the selected one. So let us see how this problem we are going to solve. So let's solve the problem. As evident that we have two alternatives, one is alpha, another one is beta, and the useful or the economic life of the two are different. So if we see, one is having an economic life of 5, another one is having an economic life of 9. So just take the LCM of 9 and 5. This comes out to be 45. So this will be the study period for both the alternatives, or we can use the we will use the repeatability assumption to extend the cash flow up to 45 years, both for alternative alpha and alternative beta. So let's start with alpha first. So the cash flow for 5 years, 0, 1, 2, 3, 4, 5. The purchase price is given as $10,000, and the annual expenses, they are given as $2,500. So let us first compute the present worth of this cash flow. So if I compute the present worth of this cash flow, 10,000 is already at the present point of time, so no need of any conversion. And these are the annuities which are given. So I can convert these annuities into present point of time. I've already told you that whenever we are solving a problem with the help of annual worth or with the help of future worth, it's simple if we convert all the transactions at the present point of time, or calculate the present worth first and then transfer this present worth either into annuities or into future worth, as may be the case. So if I just convert these annuities into present point of time by using the relation P equal to A 1 plus I to the power n minus 1 upon I 1 plus I to the power n. If I just fill up the values, so 10,000 as it is, A is given as 2500, 1 plus I is given as 10%, so it will be 1.1 to the power 5 minus 1 upon 0.1 into 1.1 to the power 5. If I compute this, this comes out to be $19477. Now with the using the repeatability assumption, That is, if I extend this cash flow for 45 years, 0, and this is 45, so I just draw it in a multiples of 5, 5, 10, 15, 20, 25, 30, 35, 40. So every time, this we have already calculated 19477. So for the next 5 to 10 years, if the present worth, if we calculate the present worth, this will be at the end of 5 years. Again, the value will be same. Similarly, another present worth will be at 10, and this keeps on repeating, and the last transaction of the same amount will be at the end of year 40. Of course, these end of years, they are not continuous, there is a break. Now if I find out the present worth, now treating every transaction as a future transaction, we can compute what is the present value of these transactions. So if I compute the present worth, of course this present worth is for up to 5 years, and this is up to 45 years. So the first transaction is already at 0, so no need of any conversion. For the second, treating the second transaction as the future and computing it at the present point of time. So using the relation f equal to p 1 plus I to the power n. So f is given, we are interested in finding out p, so it will be 19477. So f is given, and we are interested in finding out p, so it will be 1.1 to the power 5. Similarly, there will be another term 19477, 1.1 to the power 10, 19477 to the power 1.1, 15. And similarly, if we write, the last term will be 19477 over 1.1 to the power 40. If I just simplify it a bit, 19477 will be 1 plus 1 upon 1.1 to the power 5 plus 1.1 to the power 10 plus 1.1 to the power 15, and the last will be 1 over 1.1 to the power 40. If we compute the value of this comes out to be $50675. So this will be the value or the present worth for the option alpha. So let's see what we have calculated. If I draw the cash flow 0, 1, 2, 3, 4, 45 years, this P we have calculated. So this P is we have calculated. But since we are interested in using the annual worth method, so we can just convert this P into annuities. So if I just draw it on the cash flow, the problem is what will be the value of this A, so that these two cash flows, they are equivalent. So directly if I write the relationship A, we can compute P I 1 plus I to the power n over 1 plus I to the power n minus 1. So if I just fill up the values, P is given as 50675, I is 0.1, 1.1 to the power 45 over 1.1 to the power 45 minus 1. So this comes out to be $5138. So this is the present worth of alpha model. So on similar lines, let us compute this is the annuities for model alpha. On similar lines, let us compute this for beta. So for beta, the life is given as 9 years. And the purchase price is given as $25,000. And the annual expenses they are given as $1,200. And finally the salvage value is given as $5,000. So it is a kind of earning, so the arrow will be upward or cash inflow. Now if I just compute the present worth of this cash flow, so 25,000 is straight away at time t equal to 0, so no need of any conversion, converting these annuities into present point of time. So this will be 1200a 1 plus I to the power 9 minus 1 over I 1 plus I to the power n9. And of course, if we consider these signs to be positive, so this is a transaction upward. So of course, this will be with a negative sign, treating this as a future worth and converting or transferring this at the present point of time. So this will be F upon 1 plus I to the power 9. So if I calculate this, this comes out to be $29790. So this is for 9-year economic life. Now if we just extend it, the same cash flow to 45, so I'm drawing it in a multiples of 9, 18, 27, 36, and finally 45. So for the first 9 years, this is the present worth 29790. Same transaction will be there at the end of 9th year. Another one is at the end of 18th year, then 27, then 36 is the last one. So again, all these transactions, they are of 29790. Why? Because we are using the repeatability assumption. Of course, these end of years, they are not continuous. So if I treat every transaction except this 0 as a future transaction, I can compute what will be the present worth for 45 years. So if I write, it will be 29790 plus 29790, treating this to be the future worth and converting it at the present point of time using the relationship F equal to P1 plus I to the power n. So it will be 1.1 to the power 9. So another term 29790 over 1.1 to the power 18, and the last term will be 29790 upon 1.1 to the power 36. So if we compute this, or if we simplify it a bit, 29790 1 plus 1 over 1.1 to the power 9, then we have another term 1.1 to the power 18, 1 upon 1.1 to the power 27, and the last one will be 1 over 1.1 to the power 36. If we calculate, this comes out to be $51017.855. So what we have computed? We have computed 0, 1, 2, 3 up to 45. We have computed the value at the present point of time. So this is what we have calculated, and this is the present worth we have calculated. Now if I just go by the equivalence, what I am interested in finding out the value of A, so that the two cash flows, they are equivalent. So what will be the value of A? What will be the value of this A? So simply, if I just convert this present into annual worth, of course this is for beta model, it will be equal to P into I 1 plus I to the power n upon 1 plus I to the power n minus 1. If I just write down the numerical values, so it will be 51017.855. okay, I is given as 0.1, 1.1 to the power 45 over 1.1 to the power 45 minus 1. So if I compute this, this comes out to be $5,152.8. Now to summarize, so the annual worth for alpha, this comes out to be, we have computed this to be $5,138, and the annual worth for beta, this comes out to be $5,153. Now both the transactions, they are in downward direction, so that means it is a kind of expenditure. So the preferred option is the one where we are having less expenditure, and if we compare the two, this will be the preferred one because the expenditure is less for this model alpha as compared to the model beta. So this is the preferred option or alternative. So this is the solution to the problem, and the important thing to note here is that whenever I am repeating it once again, that whenever we are solving the cash flow comparisons based on annuities or on future worth, it's always better to compute the present worth first and then transfer or convert this present worth into annuities or future worth. So this is all about the annual worth method. Thank you very much. Hope this will give you some insight of how the method is applied for solving problems or for decision making when we have to make comparison. And in the coming lectures, we will see the future worth method. So thank you very much. Have a nice day.